Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to today's Design News webinar. These robots are made for walking, sorting, sensing, and more. Sponsored by Harmonic Drive and IGUS, broadcast by Informa. I'm Rob Spiegel, and I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. On the right-hand side of your screen, you'll find the Navigation Center, which will allow you to learn about today's speakers, download resources, and participate in the Q&A session that takes place at the end of our presentation. Before you leave us today, please complete our webinar survey, as your feedback will provide us with valuable information on how we can improve future events. If you experience any technical difficulties, refresh your webinar console within your browser window or type your issue into the Q&A area, and we will be glad to offer one-on-one assistance. Lastly, we're so glad to have you joining us remotely today, but did you know you can also learn and connect in person at our live events? Please consider joining us in a couple of weeks at MD&M West in Anaheim, California, February 3rd through February 5th. You can learn more about this event in the resources widget. Now on to the presentation. Discussing today's topic is Jim Leonard, VP of Sales at Harmonic Drive, and Jan Henneke, Product Manager, RBTX and Low Cost Automation at IGUS Inc. To learn about our speakers, please visit the Info tab in your Navigation Center. From here, we're going to pass it over to each of the speakers for some brief information on their background and relevancy to today's topic.
Thank you, Rob. As Rob indicated, my name is Jim Leonard. I'm the Vice President of Sales at Harmonic Drive LLC in Beverly, Massachusetts. And I've been with the company, about 11 years now, and I've been in the motion control industry going on 38 years. So a little bit about Harmonic Drive. We engineer, we manufacture gear sets, gear heads, and servo actuators. These products are used in various industries, including medical, semiconductor, robotics, aerospace, machine tool, defense, and other industries as well. How we began, back in 1955, a gentleman by the name of Walt Musser, who was a U.S. inventor, he developed a new type of gear technology, which was called the strain wave gear, and started to commercialize the product back in the late 50s, early 60s, and through the 60s and 70s. We formed several different parts of our organization and had some, as of late, major expansion with our manufacturing facilities over the last 6-7 years. We have worldwide manufacturing, globally headquartered in Japan, where we have 2 large facilities that manufacture strain wave gearing. Here in the United States, our facility is in Beverly, Massachusetts. Then a sister company over in Germany, Limburg, Germany, where we also manufacture strain wave gears. So we are a global company with manufacturing facilities around the world and able to manufacture these products with the same quality standards throughout the globe. With that said, I'm going to pass it over to Jan and have him introduce himself. Jan.
Thank you for joining us today and talking a little bit about robots, walking, sorting, and sensing. I'm here in Rhode Island in our robotics lab. You can see one of our robots behind us. To talk a little bit about IGUS first, though, we're a company that for over 60 years now creates motion plastics. So these are started all with these plastic liners that can create motion without having to lubricate them. And so we kind of over the last 60 years have developed a really broad range of products from literal plain bearings over to linear slides that use those plain bearings. Also, we just started a lead screw production here in the US. So we actually roll those lead screws here in the US as of the beginning of this year. We have all kinds of other projects like slewing rings, but also cable management. So you'll see something like this in the industry a lot. So we have those cable carriers, we call them E-chain. But then also we have Triflex, which is with cable assemblies and connectors inside. So really a large offering of industrial automation products. And the automation business unit that I get to work with really is using all those components together to create what we call low-cost automation. So the idea is we have a lot of knowledge of performance polymers, plastics that create lubrication-free motion in-house. And we take those really to put everything together into one solution that we can offer for low cost, which is kind of the whole purpose of what we do. So in the numbers a little bit, the whole business unit started in 2019. So far, we've sold roughly 3,000 projects and over 20,000 robots are sold and installed. We do these remote support calls in our labs. We have a lot of labs all around the world where we can do live video calls, explain customers, try to troubleshoot and understand, solve questions that they have in their automation journey. That is also something that we try to address with our marketplace, rbtx.com. The idea is that really everybody has different automation needs. Some people are very new, they just want to get started, learn a little bit. Some people, they really know what they're doing and they have a lot of years of experience, and for them it's the convenience of trying to find the right component, trying to find the right help. And so we really want to see that we can provide resources to all of these different characteristics and the different goals that people have across the board. Here's a little bit of an example of what we do on a daily basis. We try to post as many solutions online as we can, and we try to be price transparent. So this is what you can see here. On the website, you'll find over 600 solutions that have a variety of components that are available for purchase on the website. And you have an immediate price transparency, and you can see how much a solution costs. Now, this might not be exactly what you need, but many customers find this super helpful because it gets them something to get started with. If you want to learn a little bit about quality control, you can find the solution online. There's a video attached to it, but there's also documentation on the camera, so you can dive a little bit deeper and learn more. It's a great place to get started in automation. Other things that we do is we try to add as many configurators as we can. The idea there is that we're really leveraging those configurators for you to browse around, learn, but also understand what is possible and what's easy to get. Perfect. With that, we're going to dive into the questions. But if you have more questions other than that, feel free to reach out to us over rbtx.com and book a live demo.
All right. Thank you, Jan and Jim. Let's dive into the topic. First question I have is, how are low-cost robotics enabling small and mid-sized companies to automate processes that were previously out of reach? And I'll turn to you, Jan, to get us going on that.
Yeah, it's a good question because typically how the industry works, there's an end customer that's looking for automation. There's an integrator that is basically putting automation together. There will be an OEM, somebody that produces maybe the robot, and then there's sometimes even a distributor in there. So the idea really is you have a lot of knowledge levels that you need to align. And so what really we've been trying to do is we've been trying to see what are the easy applications that maybe somebody could try to solve themselves if the hardware and the software is easy enough to use. So beforehand, to really make sense of automation, you would have to have a massive ROI calculation, understand what's worth it, will this investment pay off? But there's also something to be said to invest in the knowledge of your workers on your engineering teams. And so what we're really pushing for is get started with something that's low cost, so that you have a low investment on the hardware side, and then have your team learn with it. Try to do something simple. Don't look at the ROI first. Just look at developing your own team, make the team comfortable with automation, and then gain that knowledge to then take the next step into the high ROI applications with more knowledge internally in the team.
Thanks, John. Would you like to add to that, Jim?
Yeah, generally, low-cost robotics, they're fundamentally changing who can automate what was once the domain of large enterprises, big companies with capital budgets, specialized engineers, long payback periods. It's now accessible to smaller companies and mid-sized companies. And that's because both the technology stack and the business model have shifted. So yeah, bottom line, low-cost robotics are definitely enabling smaller companies to automate.
Okay, thank you, Jim. We're hearing an awful lot these days about humanoid robots, but I'm curious as to whether they're gaining much traction and in what sectors they're gaining traction. What are you seeing out there, Jim?
Yeah, definitely humanoid robots are increasingly gaining traction. Although widespread consumer level deployment is still emerging, real industry adoption is accelerating across multiple sectors, and that would be a result of advances in AI, perception, dexterous hardware, and cost reductions that are driving the shift from lab prototypes toward practical applications and some pilot deployments. So the market is definitely growing rapidly. It's projected to expand significantly through the rest of the decade and beyond. Long-term estimates are suggesting it could reach trillions of dollars by 2050. I'll probably be retired by then, but it'll be good times. Some of the sectors where humanoids are gaining traction: manufacturing and logistics, healthcare and elder care, logistics and warehousing, retail, hospitality, customer service, education and research, defense, security, high-risk tasks, and consumer and domestic environments. So those are all emerging, and they're definitely moving beyond research labs, and they're starting to gain traction in manufacturing, healthcare, logistics, customer service, etc. So we'll see more over the next several years.
Great, thank you, Jim. What are you seeing out there, Jan?
Yeah, I think we just finished CES, I think at the beginning of January. You can see a tremendous amount of investment in the humanoid space. You see a lot of startups, a lot of technology that's moving into the space, which is really good to see. A lot of really, really smart people trying to solve this problem, and a lot of money behind those larger humanoid companies, startups, as well. So that's really exciting. I think, where do we see them in use already? I think a lot of people talk about home use. They talk about all kinds of applications, but you can see that some humanoids are being deployed already as test phases in the big car manufacturers, but also bigger OEMs in Europe, where they have committed to trial run humanoids in their production line. So that's really, really interesting to see. I think that's where I see the immediate implementation of those robots already. If it comes to home robots and other industries, I think we're still far off. There's a big topic when it comes to safety. But I think it's very interesting to see how fast these robots are getting deployed in actual factory settings, although it's just testing, it's not full production.
All right, thanks. Now, talking about humanoid robots, how are advances in materials, lubrication, and bearing integration improving the durability of strain wave gears in humanoid robots? You want to take that one, Jim?
Sure. I would say modern strain wave gears benefit from improved flex spline materials, surface treatments, optimized tooth profiles, and the integration of cross roller bearings. So these advances are increasing torque capacity, they are reducing wear, improving thermal performance, and in general, just extending service life under some demanding motion profiles typical of humanoid applications. So that would be the primary areas there.
Okay. You like to add to that, Jan?
Yeah, I think when it comes to those the needs of the humanoid market, it's all about size, it's about efficiency. So ideally as small as possible with the most efficient power transmission, but then also you want to have strength, you want to be safe, but also you want to be very diverse and you want to be able to do all kinds of things. So it's a very, very complicated project. I've talked to a couple of people in the industry that said the normal gearing doesn't do it always. There's a lot of custom work that's out there in the industry. So as we're not fully involved in this, I'm very, very interested and excited to see what's coming from the new innovations from companies like Harmonic Drives.
Great. Thank you. Okay. How do you see the balance between affordability and performance evolving in robotics over the next few years? So put on your future glasses and let us know about that, Jan.
Yeah, it's all about the cost equation, right? How much do I get for what cost? In the past, it was, what is my biggest problem and how can I solve this with automation? I think now that we're creating systems that lay on top of the robots, that make the robots easier to use, it will actually become more interesting how diverse you can use those robots with. So basically to say, the easier we make it to install a robot, the more easier it is to implement them. In the classic robotic industry, I would say there's been a little bit of a knowledge gap that is between the robot manufacturer or the systems need and then the end customer. So really, you needed integrators, and you still need integrators to create systems that are safe and work really well and reliable. As we look into the future, I think software will take up some of that knowledge work so that the people that do integrate robots will be able to do more. The easy applications will be able to be solved by the end customer itself. And I also think that the robot OEMs will go closer to the solution. While in the past, the robot manufacturers and other providers have focused very much on the component itself, on the technology that's in there, and improve that, I think the whole industry will move closer to the application level and solve those. So I think that's going to be very interesting. It'll allow customers to be faster with the installation and the implementation. And I think it'll create knowledge pockets in the industry that will be able to solve a lot of problems really, really fast. And so that's what I'm excited for.
Okay, thank you, Jan. What are you seeing out there for the future, Jim?
Yeah, I have to agree with Jan there. Definitely the balance between affordability and performance in robotics is shifting rapidly. Over the next few years, I expect to see some big trends. Performance is improving faster than cost is rising is one. Tiered market's going to mature. Software and AI will be key cost reducers. Manufacturing scale and competition is going to lower prices. So yeah, in general, today's robots are expensive because they're precise. Tomorrow's robots are going to be precise because the tech itself is becoming less expensive and smarter.
Okay, thank you, Jim.
Mhm.
I'm interested in what's underneath the robot skin, so to speak, and what components and technology are enabling precise human-like movements in robotics. And actually, if you wanted to, you could look beyond just humanoid robots because, precision is going to be important and is always important, whether it's a humanoid robot or some other robot. But I'm curious about what developments you're seeing in the components and technology that are helping move the robots forward. And Jan, why don't you start out with that one?
Yeah, there's typically how that problem is solved in the industries with encoders. Your control system tells the robot to move to a specific position, and then there's encoders in the system that will track how far you moved and where you moved, and then it'll give you the feedback of, okay, I tried to go to position A, I hit it, or I didn't hit it, and now we have to adjust. There's definitely a lot of advancements when it comes to that. But there's also interesting trends for external validation, right? So that you could put a camera somewhere and you could validate if the robot moved to the right position. And then there could be a control signal that's sent from the camera back to the robot to say, you think you're there, you're not, go there. And so lots of different interesting ways to look at precision. Also on the system level, you could detach different motion components to see where exactly do you need the precision. Right? You can move something that is precise to an unprecise component as long as you know where that position is. So lots of interesting ways to look at that. AI definitely being part of that in the future.
Okay, Jim?
Yeah, I agree. Precise human-like movement in robots emerges from tight integration of mechanics, of sensing, of control, of AI. The goal is smooth, adaptive, coordinated motion rather than, rigid point-to-point accuracy. So, in general, human-like robotic motion, it's not about being perfectly precise. It's about being precise enough, compliant enough, and smart enough to adapt in real time. I agree with Jan. Position feedback is critical. Encoder technology, and also torque and force sensing as well to be integrated into actuators.
Okay, thank you. Why are strain wave gear trains particularly well suited for humanoid robot joints compared to the traditional planetary or spur gear system? So we're going to let you get a little bit into the details on that one, Jim.
Okay, very good. Strain wave gearing. One of the biggest advantages, offers very high reduction ratios in a compact, lightweight form factor with virtually zero backlash. So comparing to some other technologies that have a little more mass associated with them, little, bigger envelopes, and the strain wave's ability to also have hollow through bores, so you can route cabling and those types of things through the center of the device. So it enables high torque output at each joint without bulky transmissions, and it supports human scale strength. It supports dexterity, high torque density. Allows joints to achieve smooth motion, precise human-like motion, and to do so in a limited space.
All right, Jan, you want to add to that?
That was, I don't really have anything to add to that. That was really good, Jim.
Okay, great. All right, what role do modular components and open source software play in making robotics more accessible? I'm particularly interested in this whole notion of open source software helping to enable robots. And I'm also curious when we talk about open source software, whether AI plays into that. So you want to take that one on, Jan?
Yes, yeah, I'm particularly excited about this. I think we've seen a lot of end customers that are automating their factories with our help, with third-party help, but also sometimes themselves. And it's very amazing to see what everybody comes up with. We have a lot of robots in the field, and to just talk to customers about what they're doing with it, and then some of the possibilities that you can build on top of our robotic systems is really amazing, really exciting. So yeah, really the idea long term is how can we share that with other people as well. Some some techniques and some things that we do in the robotics space when you do program your robot cell or develop it, they're proprietary, and that's totally understandable. But sometimes you're also developing things that could be helpful to other people as well. And fostering an open source community is a big advantage, I think, for the industry itself. I think I can see lots of examples where customers are solving the same problems, where it would be great if that's kind of universally shared in an open forum or open source space, so that people can help each other. So that's amazing. I think what can we do on the component level or the supplier level? We can make sure that our components are modular, that they're easy to use, and that you give the end customer the freedom to do what their actual end goal is. So very exciting. I think there's a lot to come on that end.
Okay, thank you, Jan. And Jim, what do you see in there?
Yeah, just to add to what Jan was saying, modular components reduce the cost and the risk of building robots. Open source software reduces the cost and risk of making them smart. And together, they make robotics more accessible to everybody.
Okay, great. Okay, what role do strain wave gears play in enabling human robots to operate in proximity to humans safely? And I know that safety is a gigantic issue in robotics. So I'm wondering what you're seeing there, Jim.
Yeah, the inherent torsional compliance and smooth torque transmission of strain wave gearing support advanced force control and impedance control technologies. It allows humanoid robots to absorb shocks, to regulate contact forces, to behave more predictably. And these are all key requirements for safe collaboration in human-centered environments. So yeah, strain wave gears, zero backlash characteristics, and the inherent compliance with strain wave gearing. It allows the humanoid robots to just move smoothly and absorb unexpected forces, reducing risk of injury and during contact with humans. And it's precise yet forgiving motion control makes them ideal for safe operation in a shared work environment.
Okay, thanks. Now, Jan, I would imagine that you're all very involved in safety as well. And I'm also guessing that robots are more frequently working near humans than they used to. So I would imagine safety is a big issue for IGUS as it is for harmonic drive.
Yes, it's one of the most important topics, if not the most important topic. The worst thing that could happen is if a robot will injure a human being. So that's always on the top front of our minds when it comes to looking at robot implementations. For sure. I think especially the humanoid space there has a lot to still do. I think the reality there is that sometimes we're striving to make a robot walk really well, or pick something or do some very nice dexterous things with their hand. But I think safety is a part that definitely in 2026 with the new humanoid safety standards will be looked at a little bit more closely, and the industry will make massive advances to all of our benefit there this year.
Gotcha. Okay. What are the biggest challenges in integrating vision systems and sensors into low-cost robotic platforms? Jan, you want to take that one?
Yeah, it's very interesting because sensors and vision systems can become very expensive very quickly. So we frequently run into the situation that those systems are actually more expensive than the robotic component. I think what you can't underestimate is the power of AI there. There's a lot of solutions with simple webcams out there where you can do simple object detection just with a $100 webcam off of Amazon. So what we're really striving for, trying to push, is to find what are the 60 to 80% of the applications that we can solve with simple hardware? There will always be the need for the specialty products, the specialty cameras that do something very fancy and very necessary in the specific situation. But we also see that sometimes we'll easily grab the most expensive, most best camera out there if you could do it with a webcam as well. So yeah, even going back to the open source question, I think there's a lot to, if you bring together the industry, there's a lot of efficiencies to be gained.
Thank you, Jan. Last year I was speaking to you at a trade show. I think it was Automate, and we were talking about this subject, and you were telling me that AI in the software is making cameras more effective. And so in order to improve vision systems, you don't necessarily have to go to more expensive cameras. If you have the software to support it, you can take a less expensive camera and make it useful because of AI.
100%. I mean, if you look at the pictures and videos that your iPhone can make nowadays, that's pretty good, right? And you look at the total cost of that product. I know it's mass produced, but you can look at all kinds of other examples. I think, a simple webcam does it sometimes. Maybe you need a little bit more high resolution one. But really, most of the complexity or value that needs to be created is the image processing. So great, I took a picture, or great, I took a video. What do I do with it, right? So that interface with learning about what does the end user want with that picture, what are we looking at, and how do we get to that resolution? Very exciting area of the industry. I speak with a lot of founders that are starting companies that are solving unique challenges there, but also just in general to see what nowadays you can do with just a webcam. I didn't really believe that 2 or 3 years ago.
Great. Appreciate that, Jan. What are your thoughts on vision systems there, Jim?
Integrating vision systems and sensors into low-cost robotic platforms is a challenge. It's difficult, but very important, and very important step in making robotics accessible. So the challenge isn't any single component. It's really achieving reliable perception and control under tight cost, compute, and integration constraints.
Gotcha. Thank you, Jim.
Mhm.
Another thing that I'm curious about for both of your companies is your customers. I know that when I first started covering robots a couple of decades ago, the customer for the robot was different from the customer today. That was before the era of cobots. That was before the era of small manufacturers getting into robotics. So I'm wondering what you're seeing out there in terms of your customers. Are you dealing with a lot of mid-sized customers, small-sized customers? I'm thinking that both because of the dexterity and precision of robots and because the costs are coming down, that you don't have to be a large manufacturer to make use of robots anymore. Jim, you want to clue us in on that one?
Yeah, I would agree with that 100%. In the past, it was mainly large organizations with big capital budgets that would implement automation and robotics in their manufacturing facilities. Today, it's mid-sized companies, smaller companies who can make those investments and make them pay off relatively quickly. So it's definitely expanding from larger companies with much higher resources to smaller organizations.
Jan, what are you seeing?
Yeah, I think technology has become easier to use. So I think that's a big driver for more people dipping their toes into robotics and automation. I also think there's been a lot of work for solution providers, people that specialize in specific application, make it easy to understand and easy to invest. This could be a palletizing company that kind of can already, before you engage, tell you what your ROI is. They show you an interface, they show you a really well-designed sales pitch to make it easier to buy into and invest. But I also think there's the market forces that really drive people that they have to automate. I frequently see customers that have production lines not running because they don't have the people. That's something that usually it motivates quite a lot to automate if your production lines can be run. And then there's all the other incentives to automate that people always talk about. It's ROI, it's quality, it's all those things. But I think there's a lot of market forces that now force even the small to medium-sized manufacturers to automate and compete. But also the technology is getting better and better and more fun. And I also think it's more and more people learn about it in school already. You see large investments in schools into robotics labs. AI robotics is the new cool thing to study, and I think that's going to really help us bring the industry forward and install more robots in the US, because the truth is the robot growth, installation growth, has not been that much. It's usually the single-digit growth or something like that, although we have a need to double, triple, quadruple the amount of robots that are installed on a yearly basis here in the US.
Okay, thank you. Talking about different aspects of what people are looking for in robotics, I'm curious as to what are the needs of your customers. Certainly, I would imagine a lot of your development for both these companies have to do with the needs that you're seeing that your customers have. We're seeing a lot of talk about worker shortages. That doesn't necessarily, I'm not sure exactly how that translates into the kind of functionality you're developing or the type of robots you're developing, but I'll bet it has some effect on that. I'm also curious about what other needs are driving your customers. Is it that they want faster? Is it they want more precise? I imagine they all want all of these, but my guess is that there are certain specific needs that your development is designed to fill. Want to clue us in on that a bit, Jim?
Yeah, certainly companies need to be more competitive, more than ever before, and automation helps with that. It certainly allows them to build products quicker, more reliably, more consistently, and those are the types of things that organizations need to be able to do to compete and thrive. So yeah, as far as our particular sector, they're basically looking for higher performance when it comes to accuracy, repeatability, low backlash, torsional stiffness, things of this nature that'll allow them to build actuators that will improve performance overall.
Okay, your thoughts on that, Jan?
Yeah, I think looking at the industry, the small to medium-sized manufacturers, I think 95% of problems can be solved with existing hardware. I think the problem is there's not enough people that put the hardware together to really make it work, and then the price point of that hardware. So I think that's what we're optimizing for. We're optimizing for lower cost price points on the same specs on the hardware, and then how do we efficiently put it together so that it doesn't require 2 or 3 months of an engineer's time to build a robot cell. Then there's obviously the other 5% where you really you have manufacturing challenges where you need to define new manufacturing processes. You need to maybe push the limits of some of the hardware that is out there. But I think 95% of the problem is to put the right hardware together in a cost-effective manner.
Okay, got you. Okay, everybody's talking about AI. And that topic has not only dominated the technology world, it is dominating the stock market. But we're not talking about the stock market. I'm interested in how AI is advancing robot capabilities. And I'll start with you on that one, Jim.
Yeah, certainly is playing a big role. The ability for machinery to uh, perceive what's going on in the environment and to make decisions for itself, and it's really exciting, and certainly adding to the productivity of machine design. And uh, the technology is uh, growing exponentially, and it's just going to be really interesting to see where we are in another couple of years.
I'm going to pause there for just a second. You say in a couple of years. That is the amazing thing about AI. Ordinarily, when we're talking about a new technology, and you had mentioned it before on robotics, going, look what's going to happen by 2050. We talk in terms often of decades in terms of development. AI is the only technology I've seen where you can say something like you just did. Let's see what's going to happen in the next 2 years. That is astoundingly fast given how we ordinarily see technology development. Let's see what's going to happen in the next 2 years. That is amazing. Jan, what are you seeing in that area?
A lot on the controls front. Very interesting chip design, controlling actuators. Yeah, other than that, on the solution level, you have processes, so you can automate like a pick and place or something like that. There you're very deterministic. You go from position A to position B, right? But then you also have process automation, where basically you'd want to do some welding, you want to sand something, you want to polish something that's less deterministic. And so basically, because maybe the surface is a little bit different, you need a little bit more different pressure. You really need to have a smart system that adjusts easily to create the quality that you need. And that's where AI can also help on the solution level. But so basically on the controller level to make the robots better, more precise, but then also on the application level to understand better the quality that the project is providing.
Gotcha. Okay, thank you. Jim, how do zero backlash and high torque density characteristics of strain wave gears impact precision, balance, and repeatability? Now, you had talked about zero backlash earlier. I wonder if you could, give us a little more detail on zero backlash and high torque density, those characteristics, and how they improve precision, balance, and repeatability.
Yeah, sure. Zero backlash, it allows immediate torque response and precise joint positioning, and it's these are essential for balance control, for gate stability, and high torque density. It enables strong responsive joints without adding mass to the distal limbs. So you're improving dynamic stability and repeatable motion under loads in humanoid type applications.
Okay. Are you seeing anything there, Jan?
No, I think that was a really good response.
Okay. Now the question is when you do with components and technologies, because I know that an awful lot of the advances that you're seeing come down to individual developments and individual components that you're working with. And I'm just wondering what you're seeing as the most important developments in components that are allowing a more useful robot, whether it's in medical, whether it's in manufacturing. I would imagine that there are some components and technologies that are more important than others when it comes to taking robotics to the next level. You want to give a crack at that one, Jan?
Yeah, I think when it comes to precision, we covered this with the encoders and then the external validation. But I think what's really going to help us broadly improve the adoption of robots is the usability and the ease of use. which is the same. But basically, the idea that we make the robots easier to integrate, easier to use, easier to adjust as well, make them more flexible. And I think that's really on the software and application layer of those robots.
Okay, thank you. And what are you seeing, Jim?
Yeah, with servo actuators for use in robotics, it's all you've got to look at all of the elements that go into these mechanisms, and you've got your feedback devices, you've got your servo motor. You might have an internal servo drive with field bus communication. Usually that's accompanied with a servo grade gear train. Could be strain wave, could be planetary, and it's really the integration of all of these elements. Potentially including force sensors, torque sensors, and it's the integration of everything that makes a valuable servo actuator.
Okay, great. Thanks, Jim. Thanks, Jan. And that takes us through the regular presentation. And now we are on to the Q&A section of this program. To participate, audience members, select the Q&A icon in your navigation center, then just type your question into the available text box before checking send. If we're unable to answer all submitted questions during today's webinar, we'll be sure to share these questions with our speakers who can reply to you offline. Okay, and the one question that I have here is is great to see all the HW for robotics is well covered in this webinar. For those companies creating their own application-specific multi-axis robot, what control software do you recommend? Jim, why don't you do the first crack at that one?
Yeah, I'll be honest, I'm not a controls expert. So if Jan's prepared for this one, I would be happy to pass on to him.
Okay. Jan, what are you seeing in that regard to software?
I don't know that I know of a software company that offers kind of plug and play for your own hardware. It seems like to me that most multi-axis, six-axis robot companies have developed their own proprietary stack. So this goes from the electronics over the control system to the software that it runs. I do not know, and I'm sure there is one of a company that would provide that as a white label, for example. I'm sure there are some, but I don't know which ones there are out there.
Okay. Now, when you're working directly with, say, a new customer that's using robotics for the first time, my guess is that you have some software backbone that goes along with the robots, even if it's just in a basic form.
Oh, yes. So most robots, we offer our own robots like the Rebel you can see behind me, but also some of the industry standards when it comes to robotic systems. And most of all these robots have their own operating system or way to communicate. And then you use them with a master controller like a PLC to do the scheduling of all the actions that need to happen in the robot application. So usually there's a master control. That master control says, robot, go do your task. And then the robot says, I'm done with my task. And then that master controller would say, all right, now enable this component here to eject the part or something like that.
And I'm curious, I would imagine that, in the past, I remember looking at robot history, we've done some stories on robot history, basically when the robots were first deployed in the auto industry, there was a programmer attached to each robot, and that programmer was going to live with that robot, and which is a very expensive proposition. I'm guessing now that your customers don't need to be programmers in order to run your robot. So I'm curious as to what degree of software literacy they need to have to run your robots.
Yeah, I mean, from the IGUS side, really, I will say it's easy to move a robot from A to B. You know, you save a couple of points, you jog the robot around, move it around in space, you save those, you say 0.1, 0.2, 0.3, and then in the program you will say move to 0.1, move to 0.2, move to 0.3. Okay. Now those are the basics. Every robot system kind of works like that, and I find that most customers within 10-20 minutes are able to master that skill without any problem. No programming experience required. Okay. That's great, but it does come down to the application that you're trying to solve. You know, if you're trying to integrate a vision system, or you're trying to do a lot of handshaking, so talking to sensors, typically that becomes a lot more complicated, and programming knowledge really does come in handy then. It's not impossible, but it does come in handy.
Okay, great. Here's one from Lisa Pierce. I think Jan mentioned something about space earlier. How are robots and robot cells being designed to fit into smaller spaces? This is particularly important for existing operations that want to automate more. Thoughts on that?
Yeah. We do have that quite a bit, where, you know, there's just so much space in a factory. So it's, you know, there's small robots, yes. There's small robots that can do tasks, very precise tasks too. So some of the robots, you know, this robot here particularly is not a really massive robot. So that's typically a good choice to look at some of the smaller robots out there. But sometimes it just requires a lot of creativity. You know, if you don't have much floor space, maybe you hang the robot from the top and then it looks down, or you mount it on the side. So designing something for a small space, yes, you can use a small robot, but usually you have to be a little bit creative with how you lay out the space, how you design the system, and so on and so forth.
Okay, want to add anything to that, Jim?
Yeah, just as far as you know, robot envelope in general, you know, miniaturization of the joint actuators is an important aspect of that, and that's what our strain wave gearing technology allows you to do, is to really develop a compact joint actuator that allows the overall size of these robots to be miniaturized.
Okay, great. Now, this question is related to sectors. Both of your companies sell into multiple sectors because, you know, the robot components are going to be useful, whether it's in a similar ways, whether it's in a factory or whether it is in a medical setting. So the question is, how do you see robotics evolving in non-industrial sectors such as healthcare, agriculture, or logistics? And that one goes to Jan first.
Yep. Those three have really unique challenges, right? Healthcare, your margin for error is really low. You can't mess up, right? So you need a super reliable system there, more reliable than you need to be in manufacturing, right? If you have, let's say, every once in a while you have a production part not be produced accurately, that's fine. That's probably fine. In healthcare, it's not. So that's a challenge there. Agriculture, you need to be available. You need to be robust enough to be outside. You need to probably work with a bunch of different sizes. You need to be a bit more flexible. And then logistics really is hard because most of the time, logistics automation really only pays off on the large scale. So it's really hard to just start with something. There are some couple of things like palletizing and so on and so forth, but I think it's hard to just say one thing here. But I think humanoids offer a lot of promises to solve some of these problems. But in the end of the day, all these industries have their individual challenges and hopefully cool solutions that people come up with.
Okay, thank you, Jan. Jim, you want to add to that?
Yeah, I would say robotics in non-industrial sectors, it's moving away from novelty and pilot projects to mission critical infrastructure. So it's driven by labor shortages, aging populations, cost pressure, and the maturity of AI. And unlike factories, these environments are unstructured and human centric. So the evolution is less about raw precision, more about adaptability, safety, and autonomy. And it's evolving from the automation of tasks to augmentation of entire systems, and quietly becoming essential infrastructure.
Okay, thank you, Jim. Thank you, Jan. One last question, and that is, what are the barriers you're seeing to robot development? Are there any, whether it's physical challenges in terms of how much can you do with the physics of movement or miniaturization? I know that there's some inherent barriers. I'm wondering what you're seeing as particularly high fences to jump in the development of robotics. Jim, you want to start off on that one?
Yeah, I would agree. A few obstacles. One, cost and affordability. The other is miniaturization, and identifying the right solution for the task at hand. And those are all challenges that companies face when they look to automate. And it's important that you are consulting with the right organizations and getting good advice from suppliers, from vendors, and working with that accordingly.
All right, thanks, Jim. And Jan, what are you seeing?
I'm very pleasant about this. I feel like it's getting easier by the day to overcome technical challenges, and all kinds of startups are being founded every day that try to solve different aspects of the market. And so I think really in the future, it's going to become even easier to do all of these things that we're trying to do right now, enabled by new companies, but also by the incumbents that are innovating and becoming better at what they do. So I encourage everybody to start cool companies and solve unique challenges in the market.
That's great. That's a nice close there. Yeah, just encourage people to be entrepreneurs, to deal with these the barriers that will be overcome but haven't been overcome yet. Okay, well, thank you, gentlemen, for all your answers. Really appreciate it. That's all the time we have for questions today. And thanks, Jim and Jan. We appreciate your time and expertise. Thank you to our sponsors, Harmonic Drive and IGUS, as well as to everyone in the audience. We appreciate your attention and participation. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers so they also can learn from this session. On behalf of our presenters, Jim Leonard and Jan Haneke, I am Rob Spiegel. Thanks for your time and have a great day.